Hello everyone, how are you? Welcome to physioBRAIN. Have you ever thought about what it would be like if you had the chance to know whether you or someone in your family might develop Parkinson's disease in 15 or 20 years? What would you think about that? Would it be interesting to know that? So stay with me because we're going to talk about this in today's video. So, how are we going to bring this information? Why is this relevant to us? How is this research conducted? So, a research group published this article in the Lancet Journal in 2019. So, it's a highly respected study and it brought us very relevant information. What did the researchers do? They set up some groups to observe how the brains of these people and some components of the brain behave in a group of healthy elderly individuals, right? Considered to be without Parkinson's disease or any associated illnesses. So one group consisted of people without Parkinson's disease. They evaluated a group of people with unilateral Parkinson's disease, that is, Parkinson's disease affecting only one part of the body, one side of the body, and they analyzed the third group, which was people with bilateral Parkinson's disease, where the disease involvement is already a bit more advanced and affects both sides of the body, all right? But they had one more insight. They analyzed two more groups, and what are these two groups? They looked at a group of people who have a gene that can indicate the presence of Parkinson's disease, which is highly associated with the presence of Parkinson's disease in general. That's what it is who already have developed Parkinson's disease. So the person has the gene for the disease and also has the manifestation of the disease. In other words, they have already developed the disease over time. But they also identified people with the same gene who have not yet started to develop signs and symptoms of Parkinson's disease. They are younger and have not yet developed the symptoms. So what does this bring that's relevant for us? If these people have the gene, the same gene as those who developed a group of symptoms of Parkinson's disease, we can follow these people who have the gene but have not yet developed the disease in order to observe how they will behave over time, right? It's a very smart strategy on the part of the researchers. And what does this mean for us, right? It means that we can identify the differences between these groups, and we're going to show the images here on the screen so you can follow along with me to see the characteristics of some brain structures and some components, especially the behavior of the presence of dopamine, which is a neurotransmitter. So the presence of dopamine and its transport capacity, and also the presence and transport capacity of serotonin, which is another neurotransmitter found in the central nervous system. Okay, so there is a group of people without Parkinson's disease, a group of people with unilateral Parkinson's disease, a group of people with bilateral Parkinson's disease, a group of people who carry the gene for the disease and have symptoms, and the last group, people who have the gene, who are predisposed to develop the disease, but who have not yet developed symptoms. So let's try to analyze the characteristics, the differences of each group through the imaging exams that these researchers present to us, all right? So let's keep an eye on that and we'll keep talking throughout our video here. So let's try to identify these brain changes together with me here. Shall we, everyone? So in the top image, we see individuals who do not have Parkinson's disease. These images at the top, as you can see here on the side, are from individuals who do not have Parkinson's disease, and the ones at the bottom are from individuals with unilateral Parkinson's disease. So notice the difference. In the top image, we have the red pigmentation, the yellow pigmentation, especially the blue outline, right? All of this is very, very visual, okay? And in the colored image, right, we also see this yellow coloration, the red coloration, which would be considered normal for the age. But in the image at the bottom, as we can see there are changes. So you can see that one side is already more different than the other. One side is a little more affected, but the other side is very compromised. Notice that the side that has less yellow coloration less yellow coloration, less red coloration, and a greater presence of this blue coloration. This means that it is already losing structures, losing brain function because of these changes in dopamine and serotonin. Okay, we're able to see that in the image. So individuals, the image on top, individuals who do not have Parkinson's, and the one below, individuals who have Parkinson's disease on one side, unilateral. Now in this image, in the second image, we see at the top the same image of individuals without Parkinson's disease, but notice the difference compared to the image below, right? So these are individuals who have bilateral Parkinson's disease. So, right, notice, observe there that the structures are already different. The coloring is already very different. There's no longer that reddish coloring. The yellowish coloring is already weaker. It barely shows up. The blue pigmentation is getting smaller and smaller. The area where the pigmentation is concentrated is different. Notice that. So this indicates that in bilateral Parkinson's disease, which is the one being shown down there, the brain impairment is already greater, right? So this gives us very relevant information. That's why the individual shows more symptoms. They have changes in their central nervous system, and this affects their body. It affects their balance. It affects their mobility, okay? Now, let's analyze other comparative images from the same study. The image on top is that group we mentioned that has the gene but hasn't developed the disease yet, so they haven't shown symptoms. And the image on the bottom is that group that has the gene but already has the disease. So roughly speaking, we can say the group on top is the initial stage, or the stage that hasn't shown symptoms yet, and the other one is what happens as it progresses, right, over time and as the disease advances with the progression of the disease. So that's what we can identify. If we can find these people at that upper level, we can prevent them from reaching down here, right? Or we can at least delay their progression to this lower stage, okay? So we can see that at the top, it's very similar to that group without Parkinson's disease, right? With fewer changes, okay? And the image below with more pronounced changes, and what stands out the most is in this last image that we will see, which shows those people who have advanced bilateral Parkinson's disease, right? And the people who have the gene for the disease but have not yet developed it, which is that image we looked at just a moment ago, right? So we can make this comparison that those people who have the gene but have not yet developed the disease are, according to the average age presented in the study, about 20 years apart. The average age of that group was approximately 41, 42 years old, while the group that already has Parkinson's disease on both sides, which is a more advanced stage of the disease, is around 60 years old. So if we are able to detect the possibility of Parkinson's disease 20 years earlier, we can intervene in a very positive way for these people. We can prescribe exercises, we should provide multidisciplinary, transdisciplinary follow-up to ensure quality of life, and yes, to prevent the rapid progression of the disease, since we know it is a neurodegenerative disease. We will make more videos talking about Parkinson's disease. Here it's a topic I really enjoy discussing. Yes, we can also have a positive influence, all right? So I hope this difference has been made clear, that it has shed some light on how brain structures can be influenced and how over the years, as the disease progresses, it affects the quality of life and health of these individuals. Was that clear, everyone? Do you have any questions, any suggestions, any tips regarding Parkinson's disease and the detection or identification of this disease some time before the symptoms appear? Write it in the comments, share it with anyone you think should see this video, with anyone studying Parkinson's disease or those studying physical therapy or physical education. Like the video, subscribe to the channel, because we're going to keep bringing more and more information focused on the health field, right? In a quick and simple way, so that we can bring this advanced knowledge from research and scientific articles to the general community, okay? Take care, and we'll see you in the next videos.